let's say you've been given this speed time graph here. So looking at this, you can see that whatever's moving is moving at a constant speed of 3 meters per second here. So what that means is a constant speed of 3 meters per second means it's always going at 3 meters per second. So here, after 1 second, it's still going 3 meters per second. After 7 seconds, well, it's still going at 3 meters per second. So you can imagine this as being like this. Your dad's sitting in a car. This is t equals 0 here. So your dad's sitting in a car traveling at 3 meters per second. So what that means is after 1 second here, when t equals 1 here, his speed is still 3. It's still, and then after another second, well, he's still going at 3 meters per second. So at time equals 2 here, the speed of the car is still is still 3. And then after another second, well, the speed is constant. The speed is constant. So this is t equals 2, and then t equals 3. Well, the speed will be 3. It's a constant speed. After 4 seconds, well, the speed is still the same. It's a constant speed. So t equals 4. So the speed is still the same. But now let's look at the distance. Let's go back to the beginning of time here. So your dad is here sitting in a car. Now after 1 second, he would have traveled 3 meters. So the distance here is 3. Okay? Because that's what it means. A speed of 3 meters per second means you travel 3 meters every second. So after 1 second, he would have traveled 3 meters. Okay? Now, after another second, he would have traveled 6 meters. So here d equals 6. Now, after another second, the total distance here is 9 meters. So your dad would have traveled 9 meters after 3 seconds. Now, after 4 seconds, he would have traveled another 3 meters. So this will be d will be 12. Now we started with this graph here, speed time graph here, and it's always the same, 3 meters per second. Now let's look at the distance time graph now. So here this is distance, okay? Distance time graph. Now after 1 second, your dad would have done 3 meters. After 2 seconds, after 2 seconds, your dad would have done 6 meters. After 3 seconds, your dad would have done 9 meters. After 4 seconds, your dad would have done 12 meters. So given a speed time graph, it would look like this. Now, given this graph here, the speed time graph looking like this, your distance time graph would look like this. Okay. Now, this is in fact a straight line. So the minute we see a straight line in maths, we immediately jump to this: y equals mx plus c. So hopefully you would be familiar with this by now. In maths, the minute you see a straight line, well, this should pop into your mind. Now, y here, well, why we are talking about distance here, the y-axis is really distance. So we could say that distance is given by this, mx plus c. Well, the x in our case, normally when you have a graph, you have y x. So you normally have yx. But y, in our case, we are talking about distance. So we can put d into the y. Well, we can swap the d with the y, and because we are talking about time, let's switch the x to a t. So you can have this: y equals d equals mt plus c. Okay, c is the intercept here, which happens to be 0. So you can pretty much forget about the c. But my point is, normally in maths we would use x and y, but because we are talking about, well, we are talking about real life, and the y has a meaning in real life here. In real life, it represents distance. So why not use d rather than y? And x in our case here, we are talking about time. So let's use t rather than x. So this straight line, you can imagine it as this, okay? But the weird thing is, when you are given a distance time graph here, if you look at the gradient here represents speed. The gradient here represents speed. So hang on. Okay. When we first started, we were given this speed time graph. Let's imagine you didn't know this speed time graph. You're given this distance time graph. So let's pretend you didn't you didn't have that speed time graph. You are given this distance time graph. Okay. Immediately you know that this is a straight line. So immediately y inside your mind you should think y equals mx plus c. Now the gradient here actually represents speed. So when you're given the distance time graph, if you look at the gradient, it represents the speed. Because look at this here. If I give you this graph here, distance time graph, and you have to work out the gradient. Well, let's look at the gradient. The gradient, normally to work out the gradient, you would get the up and down divided by the across. Now the up and down here is distance, but the unit of the up and down here is meters. Now the unit of the across here is time. So time is measured in seconds. So the unit of the across is seconds. Okay. Now I asked you, work out the gradient. Well, to work out the gradient, you would get m. Well, in this case, m is meters. Okay. The unit of the up and down is meters. You would get the meters divided by the seconds. Okay. Now the grade. So what's a gradient? Well, the gradient. Look at this. M. Well, you can imagine this as meters per second. Now meters per second is a unit of speed. So when you are given a distance time graph, if you work out the gradient, it represents the speed. And if you ever forget the unit, well, look at this here. The up and down here is measured in meters. Okay, the across here is measured in seconds. So if you look at the gradient, well, the gradient would normally be the up and down divided by the across here. So this would be seconds. So that, well, from our indices, we immediately, well, we can change it to this. So this here is meters per second. So the gradient of a distance time graph represents the speed. In this case, the gradient is 3. And you notice that our speed is 3. Okay. So let me just give you another example here. Let's say you're given this speed time graph here. So now you can imagine your dad sitting in a car traveling at so hang on. So you can imagine this as being your dad here sitting in a car. He's traveling at 2 meters per second. So every second he would have traveled well, he's going at 2 meters per second every second. So after 1 second he would have traveled 2 meters. Okay. After another second, he would have covered 4 meters. After another second, he would cover 6 meters. He would have covered 6 meters. After another second, it would be 8. Now, if you try and plot the distance time graph for this scenario here at going at 2 meters per second, it would look like this. You see, after 1 second, your dad would have covered 2 meters. After another second, he would have covered another 2 meters. After another second, he would have covered another 2 meters. Or after 4 seconds, you can think of it as him covering 8 meters, and so on. Okay, so here you can immediately you can see this mx plus c. Now remember you could also change this to d equals m t plus c. Okay, but look at this here. The gradient here. The gradient here is, the gradient here is 2. Look, 2 divided by 1. The gradient here is 2. So the speed is also 2. So my point is that when you're given when you're given a distance time graph, if you work out a gradient, it gives you the speed. Because look at this, the up and down here, the unit of the up and down here is meters. Okay, it's meters here. The across here, the unit of the across here is seconds. So again, if m divided by seconds here, this is like this, which is meters per second, which is speed. Okay, so wait there. So when you are given a distance time graph like this, now the gradient here represents the speed. So when you are given when you are given a distance time graph here, if you extract the gradient here represents the speed. So m is right here. So this level is m. So in our case earlier, the gradient was 3. Okay, so which means this was 3. This was for the first example. In the second example, it was y equals 2x. Okay, or you can say d equals 2t. Okay, the distance was given by this. Now the gradient is 2. So that means the speed is 2. Well, my point is that when you are given a distance time graph, the gradient of this represents the speed. Okay. In one of the earlier videos, I said if you're given now the speed time graph, if you get the gradient of this, it represents the acceleration. I know it's quite confusing here. I know this bit is really confusing. So let's just wait. Let's take one step at a time. So when you're given the distance time graph, the gradient of this represents the speed. Okay, that's distance time. The gradient gives you the speed. Now let's change it to the speed time graph. Now the speed time graph, the gradient of this represents the acceleration. I know it sounds weird. Hang on. Let me just give you this here. When you are given a distance time graph, the gradient of a distance time graph represents the speed. The gradient of the speed time graph represents the acceleration. This bit's really confusing. I know. So wait there. Distance time graph. The gradient of the distance time graph gives you the speed. Now when you're given the speed time graph, the gradient of the speed time graphs represents the acceleration. So there's a relationship between acceleration, speed, and time. Okay, so I would give you another example in the next video. It will clarify things. So distance time graph, the gradient of this represents the speed. Given a speed time graph, the gradient of this represents the acceleration. Okay, I will give you another example in the next video.